It feels like something out of science fiction. You know, that's not just a dramatic hook. That is quite literally how astronomers themselves describe the sheer, mind-bending extremity of the world we're looking at today. We are talking about an alien planet that violently challenges basically everything we thought we knew about weather, climate, and planetary physics. It is a place so incredibly intense, it kind of defies logic. So let's just dive right into it. Welcome to This Explainer. Today, we're taking a virtual tour of a doomed, frankly bizarre, football-shaped exoplanet located over 850 light-years away in the constellation of Puppis. This is WASP-121b, and we're going to uncover exactly why this distant gas giant is universally considered one of the absolute most extreme exoplanets humanity has ever discovered.
To really set the scene here, I want you to ask yourself something. What would actually happen if you flew a spacecraft into a planet that rains liquid iron? Well, spoiler alert, plunging into the chaotic environment of WASP-121b wouldn't just be a rough ride. Human survival would be physically impossible in a matter of milliseconds. As you'll see, this is a world actively being ripped apart by its host star, and it's generating weather systems that are, without exaggeration, apocalyptic.
Part 1. Meet the ultra-hot Jupiter. Okay, let's start our approach by checking the travel specs for this bizarre destination, formerly known as Tylos, orbiting its star Dilmun. WASP-121b falls into a category called ultra-hot Jupiters. Think of it as a super-inflated marshmallow of a gas giant. It takes all the physical extremes of our own Jupiter and multiplies them to terrifying new levels. It's about 1.18 times the mass of Jupiter, but the radius is a massive 1.87 times larger. That means it has a crazy low density. Why? Because it sits so dangerously close to its star, completing a full polar orbit in just 1.27 Earth days. The immense gravitational tidal forces at this distance actually stretch and warp the planet so much that it isn't even a sphere anymore. It's totally deformed into an elongated American football shape.
Part 2. The blistering dayside.
As our virtual spacecraft enters the dayside atmosphere, we are instantly met with a blazing inferno. The atmosphere here isn't just hot, it's physically expanding and glowing from the sheer volume of stellar radiation it's soaking up. To understand this, we have to look at how the planet moves. WASP-121b is tidally locked. That means the planet's rotation period perfectly matches its orbit around the star. So the result? One side is subjected to a permanent, relentless bombardment of radiation, a never-ending day, while the other side faces the freezing dark of deep space in a permanent night.
So the most crucial point here is the temperature on that permanent dayside. It reaches an agonizing 2,500 degrees Celsius. That's over 4,500 degrees Fahrenheit. And this environment experiences what's called a thermal inversion. Basically, as you go higher up into the atmosphere, the temperature actually gets hotter rather than colder. This heat is so visceral, so intense, it violently rips apart water molecules. Heavy metals like iron, titanium, and vanadium, they don't even exist as solids or liquids here. They are completely vaporized into glowing gas that just hangs in the upper sky.
Part 3. Extreme nightside weather. Now, if we steer our spacecraft away from that blistering heat and head toward the permanent night side, you might think, oh great, some relief, right? Nope. The alien weather forecast on the dark half of WASP-121b is just as terrifying, and it's driven entirely by the extreme temperature differences between the two hemispheres. Wind speeds over here reach a staggering 11,000 miles per hour. Let that sink in. Roughly 18,000 kilometers per hour. These are violent, howling jet streams that completely dwarf the strongest hurricanes in our solar system. These supersonic winds are essentially the planet's way of trying to balance its temperature, fiercely carrying all that intense heat and vaporized heavy metal from the day side straight over to the permanent dark side.
When those supersonic winds cross the Terminator line into the dark, we see an absolutely stark contrast. On the day side, iron and other metals are superheated gas. But as those 11,000 mile-per-hour winds carry that metal gas to the cooler night side, the temperature drops just enough for the metals to condense. The result is apocalyptic rainstorms of liquid iron and calcium. And it gets crazier, because aluminum and oxygen are also floating around in there. Researchers actually believe it could literally be raining liquid rubies and sapphires into the deep, dark gas below.
Part 4. A bleeding atmosphere.
Zooming out from those wild weather systems, we can witness the macro-scale tragedy of this world. WASP-121b is literally bleeding its atmosphere into the vacuum of space, leaving this massive complex structure trailing right behind it. Scientifically speaking, the planet fills 59% of its Roche-Lobe volume. The Roche-Lobe is basically the gravitational boundary where the planet can actually hold on to its own material. Because the intense stellar radiation is boiling the atmosphere and the star's gravity is pulling on it so hard, the planet's atmospheric gases are expanding right past this safety limit. It's quite literally overflowing.
We know all this thanks to some incredible observations from the James Webb and Hubble Space Telescopes. They caught this atmospheric escape happening in real time. Hubble previously detected heavy metals like iron and magnesium just escaping away. And more recently, JWST mapped a massive tail of escaping helium moving at an astonishing 90 kilometers per second. Even more fascinating, this isn't just a simple comet-like tail dragging behind. The atmosphere is being stripped away into both a leading stream falling toward the star and a trailing stream pushed away by stellar winds. This whole structure spans over half of the planet's entire orbit.
Part 5. Origins and Planetary Evolution. So looking at all this destruction, a pretty massive question comes up. How did a planet this massive end up in such a suicidal orbit in the first place? And what can its tragic melting fate teach us? Well, JWST's highly sensitive NIR spec instrument took a chemical inventory across both its day and night sides to build a backstory. It found carbon monoxide, silicon monoxide, methane, and surprisingly, water vapor. Now wait a minute, how can water and methane exist when the dayside temperatures are hot enough to destroy those exact molecules? Well, the answer is those 11,000 mile-per-hour winds. When the destroyed atoms get blown to the cooler night side, temperatures drop just enough for the elements to chemically recombine into water and methane, right before being violently cycled back into the inferno on the dayside. It's a continuous, brutal cycle.
The presence of these specific gases gives us huge clues about where this planet was originally born. It tells us WASP-121b absolutely could not have formed this close to its star. Tracing its dramatic life cycle, we see it started out far away in its stellar system, originating as icy pebbles in a freezing zone, kind of like where Jupiter and Uranus sit in our own solar system. Over time, orbital drag caused it to migrate inward, leading to its current state as a boiling, bleeding world that will eventually be completely destroyed by its star.
Ultimately, why does all of this matter to us? Well, WASP-121b acts as a spectacular, natural laboratory. By studying this dying world in such incredible detail, scientists can piece together the atmospheric dynamics, the chemistry, and the evolutionary timeline of all giant exoplanets. It basically helps us map out the survival boundaries for planets across the cosmos, testing the absolute limits of planetary physics in real time.
We have just explored a world of supersonic winds, ruby rain, and boiling metal. But WASP-121b is really just one extreme out of thousands of exoplanets we've discovered so far. As our telescopes peer further and further into the dark, it leaves us pondering. What other terrifying, awe-inspiring, literal science fiction worlds are out there, quietly orbiting distant stars, just waiting to be found? Keep learning, stay curious, and thanks for joining me on this explainer.